Good evening. Thank you for watching. Here is a very simple blink program, and instead of delays, I'd like to see if I can use timer 0 and timers instead. Well, really the point is to see if I can get the timer delay that I'm going to attempt to slow down the blink rate to such an extent that I can see it with my naked eye. Okay, so yesterday I made a bunch of videos experimenting with the use of counters. So here I am here. So here I am here in this video, adding in some lines of code relating to counters. So this will start the counter counting at 0. It'll set timer 0 to start counting at 0. And then there's another while loop in here with a less than sign that says if this is true, I guess do nothing until it counts over that value I added. Hopefully I have that correct. Maybe I need a review on while loops if I have that wrong. But anyway, so here is my simple blink program. This is from yesterday. Here's yesterday's code. I guess I need these 2 lines. So I'm going to take these delays out of here. Alright, I'll clean and build. Maybe I would like to record the process of uploading this to my PIC. So I'll move it over to my camera phone.
So this is that for loop blink program I already had up and running, and now from MP Lab I am ready to click and upload the new code with the delay, the timer 0 code added. So here goes. 3, 2, 1, click. It's doing something. See, there it goes. Doing some stuff. My computer is slow. Okay, so it's blinking at a much lower rate, but now it's using the timers.
Okay, so in honesty, I found this C language code relating to the timer values somewhere else. Now I've borrowed and copied and pasted from this. Now I've plugged it into this blinking LED program. But the purpose of this video is to experiment with these numbers to see if I can get the blink rate to speed up or slow down. So the question I have, and maybe in time I will learn this, is where the original programmer got the idea to write this number. Now, timer 0 can be configured in 16-bit or 8-bit. That is according to bit 6 of the T0con register. Timer 0, 8-bit or 16-bit control bit. Set it low. Timer is configured as 16-bit timer/counter. So I'll just accept that somehow in this number that sends a high to bit 6. Okay, so 0x87, got that in the code. This would be bit 6 here, and that's correct. So I'm sending a 0 to this bit 6, T0 8-bit on the T0con register. A 0 configures things as 16-bit mode. It's not the default setting. Okay, and if I scroll down a couple pages, it talks about TMR0L, which is the low byte, and TMR0H. So I suppose if I'm using 16-bit mode, I'm making use of both of these bytes. So what does 16 ones look like? Hopefully I have that correct. 65,535. So if it's, I don't know if I'm thinking this through correctly, but like, does this number here represent the decimal value as to what can be loaded into these two bytes, the low byte and the high byte? So the real test is to see how big of a number I can put in here, and would that number be 65,535? Well, I guess we can give it a try. And then I will clean and build and then see if I get some kind of error code. Take that. So it's off screen, but it says the build was successful. So what if I put one number too large? Very interesting. It said the build was successful. You can't see it. But then I did get some of these error messages with these warnings showing up here. Could that be because I put too big of a number in here? Well, before I get too carried away, I'm going to double this number, say to 15,000, like roughly. And I'm going to upload that. And this should slow down the blink rate of what I currently have, and maybe make it half the speed. Maybe. Not sure quite how that works.
Okay, before I upload my adjusted code with that doubled count value, this is what it was currently set at. So now I will upload it through the PIC into my chip while I'm recording right now. So hitting the upload button, click. Is that slower?
All right, I'd just like to really be emphatic and really prove a point, so let's double this count value once more. I already determined that 65,000, I think, is as high as those two byte registers TMR0H and L would accept. I'm not sure about that though. Maybe I've got something wrong. I'm learning.
Okay, so this is currently the code where the timer 0 value was set to decimal 15,000. So now I will upload. Click. And the PIC18F's uploading the new code with the timer 0 value at 30,000. It should be detectably slower. And that's an off. So on, off, on, off. So that seems to be fairly consistent. So I'll conclude this experiment as a success.